This video assumes that you have prior knowledge of independent trials, random variables, combination, and permutation. Consider a Bernoulli experiment or Bernoulli trial. That is an experiment that has only two possible outcomes. We call one outcome success and the other failure. Like head and tail for a coin toss experiment. If the probability of success is p, then probability of failure must be 1 minus p, so that sum of both probabilities would be 1. The probability of success p is also called the success rate. If the experiment is repeated again, the success rate p remains the same. Thus, if such an experiment is repeated, we get sequence of independent, repeated Bernoulli trials. Consider you get registered in 5 courses in your school. The school tells you that you will win a scholarship if you score A grades in 3 courses. Notice that in this problem, you either score an A grade or you do not score an A grade, making it a Bernoulli trial. Not only that, but this trial is repeated 5 times independently, meaning that grade of one course will not affect chances of scoring A grade for another course. Now you should be interested in value of P, the success rate, the probability of scoring A in any course. The school administration looks into their record and tell you that there is 80% chance of scoring A grade for any course. So the value of P, the success rate, comes out to be 0.8. Looking at this specific problem, you are trying to find the probability of getting 3 A's in 5 courses, which would look like this. And the resulting probability looks like this. Notice that we have multiplied the probability of each Bernoulli trial because all the trials are independent. But 3 A's can also be scored like this, or like this, or this, and in several other ways. In each case, the probability of the sequence remains the same, p into 1 minus p. But since there are multiple arrangements in which you can get 3 A's in 5 courses, we have to account for all such cases. So how many cases are there? 10 cases in this example. Or in terms of combinations, 5 choose 3. This expression is called the PMF of binomial random variable. So what is the PMF of binomial random variable telling us? It is telling us the probability of getting 3 A's in 5 courses when the experiment is a sequence of independent Bernoulli trials. A more appropriate example would have been to win a scholarship if you scored at least 3 A's. This means you are required to find 3 binomial probabilities for 3 different cases and add them. So coming out of this specific example, generally the PMF of binomial random variable tells us the probability of getting k successes in n trials when the experiment is a sequence of independent Bernoulli trials. If we visualize the PMF, we plot the values of k on x-axis and probabilities of k on y-axis. The binomial random variable has this discrete shape because k can have integer values only. It also has this peak in its height. This peak shifts towards the right if p has large value and shift towards the left if p has small value. Consider an example if the value of n, the total number of trials, was 10 and value of p was 0.5. We would see the peak right in the middle of the plot. This should make sense since p is equal to 0.5 means 50% chance of success in each trial. If we get success only 50% of the time, then in sequence of 10 experiments, 5 should be the most probable outcome. If we increase the value of p, the peak moves towards the right of k is equal to 5, because in 10 experiments we should see more successes than failures. So probability of more successes in 10 experiments increases and probability of few successes in 10 experiments decreases. In other words, large values of k have higher probability as compared to small values of k. and this trend should be opposite for smaller values of p. So where should you use binomial random variable in future? When you want to model a random phenomena that has n repeated independent Bernoulli trials and you want to compute the probability of observing k successes in those n trials.